Okay, if you turn to page 9 in your notes, we're going to go over simplifying radical expressions. So, this is the radical sign, and any number underneath the radical sign is called the radicand. And we know a radical expression is simplified if there are no perfect square factors underneath the radicand. Now in this case, root 18 has a factor of root 9 and root 2. Root 9 is a perfect square factor, so we would write that as 3 root 2. Also, a radical expression is not simplified if you have a fraction under the radical sign. It's also not simplified if you have a radical sign in the denominator. So we're going to learn how to manipulate radical expressions so they are simplified and none of these situations occur. So, first, to do this, we need to know about the product property of square roots. And that says if you have the square root of a times b, you can rewrite that as the square root of a times the square root of b. And conversely, if you have the square root of a times the square root of b, you can rewrite that as the square root of ab. This is going to help us eliminate perfect square factors underneath the radical sign. So as an example, root 36, you all know the square root of 36 is 6. But I could also rewrite the square root of 36 as the square root of 9 times the square root of 4, because 9 times 4 is 36. This becomes 3 times 2, which is 6. And this is just an example of how taking out perfect square factors, we'd still end up with the same answer. Okay? So now, let's try some of the examples on the bottom of page 9. We have root 24. Now, one thing you can do before you try to do this is list all of your perfect squares. 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. Okay, so we have listed a bunch of perfect square factors. Now, looking at root 24, the only perfect square factor I see is 4. So I can rewrite this as root 4 times root 6, because 4 times 6 is 24. The square root of root 4 is 2. So this simplifies to 2 times root 6. I look under the radical, and I only see the number 6, which only has 2 factors, 3 and 2. Therefore, this is simplified because it has no perfect square factors underneath the radical sign. Now, let's look at number 2. Root 200. So I can rewrite that as root 100 times root 2. The square root of 100 is 10, and now I have 10 root 2. Again, there's no perfect square factors underneath the radical sign. Number 3, root 75. I can rewrite that as root 25 times root 3. Root 25 is 5, 5 root 3. No perfect square factors under the radical sign. Now, number 4, root 32. I can rewrite that as root 16 times root 2, 4 root 2, and again, no perfect square factors under the radical sign. So we can turn the page and I'm just going to do these quickly, and you can try to do them on your own. Stop the tape now, try to do them on your own, and then turn the tape back on and see if you got the right answers. So, root 147. Nothing comes to mind, so I think, okay, let me do a factor tree. Let me divide. Can I divide by 2? No, so let me divide by 3. 3 goes in, oh look at that, 49 times. That's a perfect square factor. So I can change root 147 to root 49 times root 3. So that becomes 7 root 3. Okay, but notice I found that out by doing a factor tree, because sometimes they won't be obvious. Like number 6. This isn't obvious, but to me it's obvious that 605 is divisible by 5. So let me take out a 5 and I get 121. Now I'm like, oh, look at that. 121 is a perfect square. So I'm going to rewrite this as root 121 times root 5, which becomes 11 root 5. Okay. Root 98. Again, not completely obvious, so let me divide by 2, and look at that. It's 2 and root 49. So I'm going to do root 49 times root 2, and that's 7 root 2. Now root 280. Okay, I notice 4 is going to go in, so I'll do root 4 and root 70. Well, that's 2 root 70, but 70 seems pretty big. Let me make sure this can't be factored more. And look at that. I come up with the factors of 70, 2, 5, and 7. None of them are perfect squares, so we are done. Number 9, root 500. So that'd be root 100 times root 5, which is 10 root 5. And number 10, root 99, be root 9 times root 11, and that's 3 root 11. Okay, so that's focusing on taking out the perfect square factor. Now, the next thing we're going to go over is the fact that if I multiply root 2 times root 2, I get root 4. The square root of 4 is 2. If I multiply root 3 times root 3, I get root 9, and that's 3. If I do root 4 times root 4, that's root 16, which is 4. But are we noticing a pattern? The pattern is, whenever you multiply a number under a radical, and the radicands are both the same, this and this end up canceling it out. So root 67 times root 67 is really root 67 squared. The square and the square root cancel out, and it's 67. So root 131 times root 131 is 131. Root x times root x is x. Root 67 times root 67 is 67. Okay? So, we're going to use that knowledge to help us with some of the next problems. So, let's look at number 3. Number 3 has 2 root 14 times root 21. Now, I could multiply 14 by 21, but that's not something I can do in my head. But I do notice when I look at this that both root 14 and root 21 have factors of root 7. So I'm going to try rewriting this as 2 root 7 times root 2 times root 7 times root 3. Now I can use the commutative property to reorder this. And I notice root 7 times root 7 is 7. So I can do 2 times 7, which is 14, root 2 times 3 is 6. So this becomes 14 root 6, and I didn't have to use a calculator. Now, let's try number 4. 5 root 24 times 2 root 8. So they both have a factor of root 8. So 5 root 8 times root 3 times 2 root 8. Again, I can rewrite these 5 times 2 times root 8 times root 8 times root 3. Now notice all I did was move these around. Eventually you're going to move them around in your head and you're not going to have to write it down. 5 times 2 is 10. Root 8 times root 8 is 8. So that becomes 80 root 3. Okay? Now, go ahead and try 5 and 6 on your own. Stop the video. Start the video and see if you did it correctly. So I have root 72 times root 128. Okay? Now, root 72, I don't want to multiply 72 times 128. I'm going to get a huge number. So I'm going to try to simplify it first. This becomes root 36 times root 2. And this becomes root 64 times root 2. Now you might think, how did you see that so quickly? Well, I've been doing it a while, and the first thing I try to divide by is 2. And it turns out that leaves me with the perfect squares. So this becomes 6 root 2 times 8 root 2. So I can rewrite that as 6 times 8 times root 2 times root 2. So that becomes 48 times 2, which is 96. Remember, root 2 times root 2 is 2. So the answer is 96. Now for number 6, root 99 times root 98. Well, this becomes root 9 times root 11, and this becomes root 2 times root 49. That's a perfect square 7, that's a perfect square 3. That's not, so I multiply them together, it's root 22, and I end up with 21 root 22. Okay, so my next video is going to be on variables.